Welcome back to the Math Professors. I've got a pretty interesting problem from Calculus 3, and we can see it here, but I always like to draw back to Calculus 1, which we have a lot more familiarity with. So in both cases, I want to show that the limit of the particular function doesn't exist at this point. So in this case, I have this blue function, f of x is equal to absolute value of x over x. And I can see graphically it doesn't have a limit as x approaches 0. Because if I approach from the left, it's going to be -1, and if I approach from the right, it's going to be +1. And we can see, since the limit doesn't approach the same spot for both sides, the limit doesn't exist. Now, we do have to prove this algebraically because, a picture really isn't good enough. And we have to call back to knowing what the absolute value is. So remember that the absolute value of x is going to be equal to -x when x is less than 0 and x when x is greater than or equal to 0. Now I have to exclude 0 in this because I know I can't divide by 0. So, evaluating this function, this is going to be equal to the limit as x approaches 0 of this piecewise function. So it's going to be -x over x because I'm just, plugging in -x in that particular spot when x is less than 0. And then it's also going to be equal to, positive x when x is greater than 0. So this is going to become positive x over x. And then we can see the limit as x approaches 0 is going to be equal to -1 when x is less than 0, and then +1 when x is greater than 0. So again, we have to show algebraically that these limits don't exist. So we have to write it as a limit from two different directions. So the limit as x approaches 0 from the left-hand side of f of x is going to be equal to the limit as x approaches 0. Now, from the left means that we have to be smaller than 0. This is what I mean by, from the left here. So as long as I choose the correct function, I can really drop its directionality, but it doesn't really matter even if you leave that in there. So the limit as x approaches 0 of -1 indeed is -1. And we can see that it's approaching -1 here. Now I also have to show the limit as x approaches 0 from the positive side of f of x has a different value. Well, this is going to be the limit as x approaches. You can drop the directionality as long as you choose, bigger than 0, so I have to choose this function. So this is going to be 1. I'll leave it in there because it doesn't matter, but the limit of as x approaches 0 of 1 is 1. Now, since the limit from the left doesn't equal the limit from the right, we can see that this limit doesn't exist. So since the limit as x approaches 0 from the left of f of x does not equal the limit as x approaches from the right of f of x, because this one is -1 on this side, and this is going to be 1 on this side. So we'd say that this limit does not exist. So we'd say that this does not exist. All right, now in calculus, in Calc 1, all we have is our domain happens to be this x-axis, and then, our outputs are going to be the y-axis. But when we move into Calculus 3, our domain is, it's got an extra dimension to it. It doesn't just have the x-axis, it also has the y-axis. So our domain is, this xy plane. Essentially the shadow of this figure I'm trying to draw here. Now, in order to show that the limit doesn't exist, I really just need that show that it doesn't equal the same value if I go from two different directions. Now again, for directionality in Calc 1, all you have is from the left, and then you also have from the right. But now if I'm looking at a domain here, to say this is the xy plane, I'm approaching 0, 0, and the function is going to live somewhere above this. You can see that. We can approach from, here, or we can approach from here. Actually, we can approach from this way, or we can approach from this way, or we can approach this way, and so on. We can approach in curves. As long as we go to 0, 0, we're allowed to approach in any direction we want, and because we have our two dimensions. So I'm going to be clever in the direction I choose. So what I'm going to do for this is I want this to simplify much like this simplified. So I'm going to let y equal x squared. So really what I'm doing is I'm going to come in from this curve here, and I'm going to approach 0, 0. Now we have to make sure that this would work. So this is going to be the limit as x comma, now remember what I'm doing is I'm changing this y right here to an x squared. Now it's important that this will still go to 0. Like I couldn't choose x squared plus 1 because as x goes to 0, x squared plus 1 would go to 1 here. So that's why if I choose x squared, I know that's still going to become, 0 as well. And then the same thing here, I'm going to have to change every y into an x squared. So this is going to be, x to the fourth, x to the fourth plus, my y squared, but my y squared is my x squared. And, this side will simplify. So this will be equal to the limit as x comma x squared goes to 0 comma 0 of x to the fourth. And then the bottom, I'm going to have x to the fourth plus x to the fourth, which is going to be 2x to the fourth. So this will simplify to just 1/2. And the limit of a constant, just like over here, is just that 1/2. Now I'm going to choose a different direction. Now I want to choose a direction so that I get a different, y value. And we can kind of see here as I come in at x squared, which is going to be this, I'm kind of coming on this curve. We can see that it's, that z value here, its output value ended up being 1/2. What I'm going to do is I'm going to come in from a different quadratic, maybe up here instead, and show that I get a different z value. So I'm going to choose 2x squared. So I'm going to let y be 2x squared. Again, this will still work. This is going to be the limit as x comma, remember y is going to be equal to 2x squared, goes to 0 comma 0. So I still have this point going to 0, 0. That's the important part, that I'm still trying to be right below this z-axis of my function, which is x to the fourth. This is x to the fourth plus, my y squared. And y is going to be 2x squared. And then when I simplify this, we're going to have this limit as x comma x squared goes to 0 comma 0 of x to the fourth. And down here I have a 2x squared squared, which is going to give me a 4x to the fourth plus x to the fourth. So this is going to simplify to 5x to the fourth. And then we know that the x to the fourths are going to simplify or cancel. So this is just going to spit out 1/5. So we can see that as we come in from different directions, one is going to give us 1/5, and the other one is going to give us 1/2. And we can see that this limit doesn't exist, just like this one. I had one limit was one number, and then going to the same spot was a different number. And that's exactly what I have here. So what we'd say is this limit does not exist. So if you like the content, please subscribe.